I've arrived after endless, endless, endless problems because our power was out. And that was really fun and great, but it's okay because I'm here and I'm ready, and we're gonna just get right the heck into it. Get my super special notes all in order. I am. I'm gonna penetrate your mind with my very own personal vitamin D. But don't worry, it's gonna be great. It's gonna be fun. It's gonna be hot. Hell yeah. Hello, Kenzie, and thank you so much for that. I love you all. Just glad to be here finally. So let's do it. This was requested by some of y'all. Y'all voted on this. Vitamin D is, of course, I mean, it's pretty huge, especially for women. I think a lot of us they tend to include vitamin D tests on our checkups sometimes. So, it's a big thing. So here we go. How's it sound, by the way? I want to make sure.
Slight delay. I want to check on the PC because I just did it on my phone.
Oh yeah, I get a delay on my phone too, but also because of the Elgato, I could totally have a delay.
Let me check with my desktop that I already had it started in. I was trying to avoid taking on my phone, but fuck it. Here we go.
Sometimes
The
you
things
gotta.
I do for love.
The things you do for love. Okay. I think one of the big things that people, when you see like the words vitamin D, it's probably on milk. And milk does not naturally just have vitamin D in it. No. We put vitamin D in milk, and we started doing that in the 1930s because the society noticed that a ton of kids had this disease called Rickets, which is thank you, which is in not so many words. We're going to specify later, but it's basically screwed up bones. And you can see in these kids right here, they have trouble standing, and one of them is very clearly bow-legged. That's the biggest indicator of rickets. So that's why we put vitamin D in milk and in cereal. So we put the D right in our milk, and every morning before you wake up, you can put additional D in your milk if you so please.
No, this is a bad joke.
Amy, always here with the bad jokes.
I already stopped.
You did stop it.
I put a lid.
Very watery. Right out the gate, you can see one of the functions of vitamin D probably has to do with bones and making sure your bones are all Gucci. So, if you have rickets, your vitamin D levels are probably below 12 nanograms per milliliter. Oh, and you're probably a kid. You can't have rickets and not be a kid. It's important. So below 12 nanograms per milliliter, that's a severe vitamin D deficiency, and it will significantly affect your skeleton. If your levels are below 20, then that's considered vitamin D deficient. That's the level right there. And these, different places report different numbers, but these seem to be kind of the these kind of, I took like an average pretty much, and this is basically where the lines lie. But between 20 and 30, you're not deficient, but you're insufficient. So you should probably do things like get more sunlight or increase your supplements. 30 to 50 is you're doing good. You're at 0. You don't have bones anymore. Oh man, you're a puddle of skin. Oh man. Anything if you have below 12, then the first thing you should do is figure out exactly why. Because as I'm going to go into later, you might have good amounts of actual vitamin D. And your body might just not be able to respond to it. So that would be really important to know. It's kind of like the diabetes thing. Do you not make insulin, or can you not respond to insulin? Vitamin D has a similar thing. Sometimes you can't respond to it. Um, or maybe there are like things in the biosynthetic pathway, which would be another case where taking a supplement is not going to do jack shit. Yeah. Um, anything above 50 is an overdose. So this vitamin, a lot of vitamins actually need to be held in a really, really tight range. Like, the 20 nanograms for sufficient, that's not a lot. So your body has a lot of ways of making sure that everything is kept in the right range. So vitamin D deficiency, hey Ender, is probably one of the most common nutrient deficiencies. It's up there probably with like iron and vitamin A, stuff like that. But it's a little different than those guys. One of the main differences is that vitamin D isn't really in a lot of foods, fish and egg yolk, and I think mushrooms. Like it's not in a lot of things. And then the other thing that makes vitamin D kind of special is that it's not a fucking vitamin. It's not a vitamin. It's a fake. It's a liar. So the World Health Organization considers it is a lie. It is a lie. And like this list is from the World Health Organization. They list vitamin D as a vitamin. They call it a vitamin. But the reason why it's technically not a vitamin is because your body can make it. Our bodies make the active form of vitamin D. For all these other guys, you have to get them from the food that you eat. You have to. Our bodies can't make vitamin A or vitamin C or any of these other vitamins on the list, which is the defining quality of a vitamin, is that we can't make it. You have D, exactly. You have D, and you have the power to make more D.
Inside me.
So what is it then? Vitamin D could more accurately be described as a hormone. And what a hormone is it's a signaling molecule that travels in your blood, defining quality, and it's long distance. It can go to like it can go to a lot of different areas in your body. This fried rice is hella spicy. Yo, Amy's been going through a fried rice phase, and she has it pretty dialed in. What have you been putting in yours? Okay, so it's a hormone. The thing that habanero peppers. That sounds good. The thing that makes vitamin D similar to the other vitamins is that there's not just one form of it. Even on this list, vitamin B1, vitamin B2, vitamin B3, like there's a lot of different vitamers. That is the literal scientific term that is used for the different forms of the same vitamin, is vitamers. So vitamin D does have different vitamers. And there's really, hell yeah, I would watch that too. Amy fried rice stream. There are a few different vitamers of vitamin D. And we're gonna take a look at some of those as a way to paint a more cohesive picture of who is vitamin D. Firstly, I'm going to settle some confusion because I think this is kind of how adults explain to you growing up what vitamin D is. But vitamin D does not come from the sun. It does not beam vitamin D directly into you. The sun does not insert vitamin D into your body. Sunlight, specifically UVB rays, are absolutely required for one of the reactions that takes place in your body that leads to the formation of the active form of vitamin D. So let's oh yeah, and also vitamin D is a steroid, kind of like cholesterol. And in fact, they're in the same biosynthetic pathway. So let's take a look at that. This is gonna be the recipe for vitamin D. This is how our bodies make it. So, of course, I always want to eat fried rice as well, even when Amy makes it real spicy.
Irresistible.
As expected, we're going to start in the skin. And this right here, this little guy right here, is 7-dehydrocholesterol. I mean, it's in the name. This is 7-dehydro. That just means that it's like basically cholesterol, but without a hydrogen on the 7th carbon. So this guy, remember, we're in the skin. It can either be converted to cholesterol with an enzyme that adds a hydrogen to that carbon, or here's what we care about: it can react to UVB light and become the next step in the formation of vitamin D. Yeah, dude. Cholesterol's fucking everywhere. It's involved in so many things. It pops up everywhere. It's freaking crazy.
Fuck.
So this reaction that takes place with the UV light, it's called an electrocyclic reaction. And what that basically means is there are electrons on dehydrocholesterol in certain areas that are gonna change position and maybe rotate a little bit. And the end result is going to be a breaking of one of those rings. So that's where's my pen? There we go. Breaking right here of one of these rings. And it's going to result in the initial rearranging of those electrons. It's going to be pre-vitamin D3. But then some spontaneous isomerization is going to happen. That just means that the electrons, again, are going to rearrange themselves, and we're going to get vitamin D3, or cholecalciferol. This is the form of vitamin D that is in supplements. It's I think all supplements that you buy over the counter are vitamin D3 or vitamin D2, which is basically the same thing, but it's like the plant version. But this is the reaction that requires sunlight. So if you live in an area that has low sunlight, you have a problem starting this whole process, which is why exposure to UVB light is so important. But don't worry too much. Tanning salons actually give you UV light and can therefore start the process of making vitamin D. This isn't the end of it, though. We have 2 more reactions in 2 more organs. The next being in your... Hello? There we go. In your liver. In your liver, vitamin D gets acted on by an enzyme called 25-hydroxylase. So it adds a hydroxyl group to the 25th carbon, and it turns it into 25-OH-D3, or calcifediol. If you have ever gotten your vitamin D levels tested, this is what they test for. They're testing for your levels of this specific form of vitamin D, and not the active form. One of the reasons for that is that this has a way longer half-life, so it's way easier to sort of catch those levels. And the other reason has to do with vitamin D's effects on calcium regulation, which we'll go into later, and I will specify later. But for now, we're gonna go to the kidneys, where the final reaction is going to take place. Calcifediol is going to be acted on by an enzyme called 1-alpha hydroxylase. It's going to add a hydroxyl group to the first carbon to make 1,25-dihydroxycholecalciferol. So easy, these names. Get it? Because it's like basically cholecalciferol, which is up here. It's basically the same as that, but it has the extra hydroxyl groups. So obvious. Anyway, we could just call it calcitriol, which is referencing the 3 hydroxyl groups. And this is the final form. This is the final form of vitamin D. And throughout the rest of this lecture, whenever I say vitamin D, this is what I'm talking about. I'm talking about the active hormone that has actual physiological effects in our bodies. And those physiological effects tend to be on our bones, our intestines, and our kidneys. Those are the three main areas that I'm going to talk about in regards to vitamin D and its effects on calcium regulation, which is that's its main job in our bodies. And the reason why we care a lot about calcium homeostasis is because it has really, really important jobs in, of course, the maintenance of our bone structure, cell-to-cell communication. That's super important, obviously. And neurotransmitter release. Calcium is usually required for neurons to release neurotransmitters. We do love homeostasis. I wish my brain had that too. I wish my mind was homeostatic. Yeah. Your hormones, and it's sad because it's like your hormones are like trying to make you all balanced in there, but then they just end up fucking it up. And it's like, bruh, don't even try if you're gonna make me like that. All right. So we're gonna see how vitamin D plays a role in all of those things, in calcium's regulation, and by extension, bone maintenance and cell communication, and neurotransmitter release. So, and of course, it's Molecular Monday. We're gonna talk about the proteins that it associates with, in order to mediate those functions. So let's get some freaking molecules up in this mother effer. Oh yeah, I should specify here. So calcium, you're probably going to see it written as this Ca2+. That's because when I say calcium, I'm actually talking about the calcium ion. In its ionic form, calcium has a +2 charge. That's going to be important later. And yeah, bone signaling neurotransmitter release. Now for the real molecules. Calcium is a molecule, but I don't give a shit because it's not protein. I like proteins. If you were here for the hi, Chrissy. It is me, the adorable sweetheart, welcoming you, yet another adorable sweetheart. That's all good. This is me disabling any cooldown I have on it. Okay, if you were here for the dopamine lecture, then you were introduced or reminded of the fact that when molecules have their functions mediated in our body, they're generally acting through a receptor. Wow. And the receptor is what sends the signal to the cell and eventually leads to an effect. So vitamin D has a receptor. It's the vitamin D receptor. Oh my god, the VDR. Now, the VDR is not like any of the classic receptors that you may have been exposed to. It is a nuclear receptor, which means that it does not hang out on the surface of the cell membrane. It hangs out inside the cell. It chills in the cytosol. And it just sort of hangs out there until vitamin D diffuses across the membrane. It can do that because it's a steroid. Diffuses across the membrane and binds to it in the cytosol. And what happens after vitamin D binds is it will bind another protein called the retinoid X receptor, or RXR, forming a heterodimer. Hetero, different, di, two, different proteins together. Heterodimer, that's what that is. When that happens, we do love retinoids. And hey, retinoid is vitamin A, so it's like two kind of vitamins working together. um oh man, bomb jokes. It cuts all
Can't
the
say
wires.
that in an airport.
No, you can't. Absolutely not. So once these two proteins dimerize, what do? They go straight to the frickin' nucleus. And they affect gene expression. They literally go into the nucleus and they upregulate specific genes that are involved in calcium homeostasis. That's par for the course for systems like this. And you saw it with we saw it with dopamine as well. When dopamine binds certain receptors and that ends with gene regulation, those genes have to do with dopamine's functions. So here, the genes that are being upregulated have to do with vitamin D's function, which is calcium homeostasis, specifically increasing calcium. We are going to be taking a look at 3 different genes and 3 different proteins that vitamin D affects in our bodies. The 3 that I at least care about the most. There's a crap ton. There's a crap ton. So generally speaking, when we know what a nuclear receptor is now. This whole process is really important because we really do need nice, stable levels of calcium. I wish that I included the chart of like the ion concentrations in our body, but it's really, really narrow, the amount of calcium that we want. It's even more narrow than what you saw in the beginning with vitamin D being, 20 nanograms per milliliter in the sufficient area. It's even smaller than that. So it's really, really important to have these nice, stable levels of calcium so that our muscles and nerves can be well supplied with it and therefore able to carry out their functions. So skeletal and heart muscle need calcium in order to contract. And our nerves, again, I just want to reiterate, your nerves require calcium in order to release neurotransmitters. And there's a lot of neurotransmitters, and they do a lot of different things, and they're very important. And if you don't have enough calcium, that whole process kind of gets ruined. You need to be able to beat your heart and move your arms and legs. So calcium supply is very important. Vitamin D knows this. Vitamin D is looking out for us. So the main way that that vitamin D increases calcium is through its action in our intestines and the kidneys to reabsorb calcium. And what I've given you here is, this is sort of, it can either be in our intestine or in our kidneys right now. The proteins are technically like slightly different, but basically the same. So on the left side, we have either the inside of our intestines, the lumen of our intestine, or we have the inside of our kidneys where the tubular fluid is, the fluid that eventually becomes urine. Then we have the cell, and then on the right side, we have the blood. So things are going to be reabsorbed from the left and brought to the right side so that our blood levels increase. So let's get into the proteins that are involved in that process. One of the genes that vitamin D upregulates upon its binding to the VDR is a protein that helps us get the calcium from inside whatever tube we're looking at to inside the cell. So the first one is going to be TRPV6. This is it's a receptor. Yeah, it's a calcium receptor that takes calcium from the tubular fluid or the inside of the intestines and brings it into the cell. It specifically binds calcium. This was just really interesting to me. Part of its chemistry was that it specifically seeks out divalent cations. So that just means ions that have a 2 plus. And it happens to bind calcium with the highest affinity out of all the other ones: magnesium, um, copper. I almost forgot. Um, so I just thought that was interesting. So now we have calcium inside of our cell, which is great, but calcium is also a second messenger when it comes to cell communication, which means that there could potentially already be a lot of calcium ions basically freely roaming inside the cell, and we don't want crosstalk. We don't want that to. We don't want our communication to get muddled.
Wow.
So as soon as calcium enters the cell through TRPV6, it is going to bind a protein called calbindin. Amazing, amazing names. And again, this is so that there's no confusion between the other calcium ions that are already there as a part of normal cell communication. So calbindin is going to shuttle the calcium from the intestines or the nephron to the other side of the cell, to a I made that name up. I fucking wish. There's a protein called that modulates calcium, and it's called calmodulin. So I made that one up too. So calbindin is going to bind calcium, and it's going to carry it to the other side of the cell.
Wow.
To another protein called PMCA. This is a calcium ATPase. So what that means is it couples the shuttling of calcium out of the cell with the hydrolysis of ATP. So it takes energy. It takes energy to pull calcium from inside the cell to outside the cell and into the bloodstream. Hold on. So the reason why it takes energy is because there is a concentration gradient, an electrochemical gradient, when it comes to all of the ions in your body. And under normal physiological conditions, you have more calcium outside of your cell than inside of your cell. And the laws of electrochemical movement and osmosis and all that shit dictate that molecules want to move into areas where they have low concentrations. So if you already have lower concentrations inside the cell than outside, then if a molecule needs to get out, it needs to require energy. That's why you need energy in order to move molecules against their concentration gradient. I believe, I might be a liar, but I believe also outside the cell has a little bit more of a positive charge versus the inside. So it's a full electrochemical gradient that makes it so that you need energy to push calcium against it. So speaking of electrochemical gradients, if we're pushing all this positive charge into our blood, we need to balance that out. But don't freaking worry, because vitamin D has already thought about that. Because here's another super secret, not so secret protein, because I pressed the button too fast, that vitamin D also upregulates. And that would be MPT1, which is a phosphate pump. This guy pumps inorganic phosphate out of our cells. Why is that important? Oh, I don't know. Maybe it's because it has a -2 charge on it, and therefore it balances with all the positive charge that's coming from our intestines into our blood. So, I mean, this is great. This is genius. Thank you, vitamin D. Oh my god, I wasn't even thinking about my electrochemical balances, and I almost super died. So, luckily, I mean, wow. And all this happens just to get some calcium into our bloodstream, so that it's free to carry out its various jobs. So this was basically what happens in the kidney and the intestines. There's a third area where vitamin D acts in order to improve calcium levels, and that is, of course, in the bone. Vitamin D promotes bone resorption, which is the digestion of the minerals in bone as a way to release calcium into the blood. as well as phosphate, but mostly calcium. We care about calcium. Um, and that might seem a little contradictory given that vitamin D is heavily associated with bone health, um, and good bone density. So I'm going to expand for a moment on these vitamin D specific functions and bring in some other contributors to calcium homeostasis. Um, because, like I said, vitamin D is a hormone. Hormones regulate each other, and they are regulated by other hormones, which is why I'm gonna take a little sippy sip here before we enter endocrine hell. Okay. So, vitamin D does contribute to the breakdown of bone as a way to raise calcium. That's just because it's so focused on increasing calcium levels in our blood. Um, that whole entire process, luckily, is very, very tightly controlled through a system of hormones that are regulated by ion concentrations and by each other. So let's take a look at what we do know. Vitamin D increases blood calcium through its actions in the intestines, kidney, and bone, and it increases phosphate levels in those same areas. Um, uh, so yeah, the point is the calcium, and even if that means tapping into the bone to get that calcium, making with this is the literal like term that is used in education on these subjects, but it's vitamin D withdraws from the bone bank, which banks calcium. Um, and it extracts those ions from the mineral form of bone, which is called hydroxyapatite. It's great. If our body has ways of increasing these ions, then that probably means that we have ways of decreasing them too, because homeostasis has to do with a balance, an up and a down, and not just one way or the other. Um, so, uh, and we need that in the event, of course, that they accumulate in excess. So this vortex of calcium regulation that I'm about to show you will make it more clear why vitamin D is more associated with bone strength and remodeling, despite its tendency to withdraw calcium from the bone bank.
Tell me more about the bone bank. Can I make a withdrawal from the bone bank?
You can make a withdrawal from the bone bank, and it'll happen a lot once we hit menopause. Boy, will it happen so much.
I like one boning.
One boning, please. You heard it here, folks.
Maybe 5, actually.
God damn it. Okay, so the other hormone involved in this process is parathyroid hormone, which is released by the parathyroid glands, which are behind your thyroid. And most of us have 4 of them. You can have 5 if you're super cool. Most of us have 4 parathyroid glands buried in our thyroid. And PTH, I'm going to call it PTH, it also increases calcium levels, but unlike vitamin D, it super acts on bone. Like, that's its thing that it does, is it acts on bone to get calcium and phosphate. And how it does that is it's kind of cool. It will bind its receptor on osteoblasts, which are bone cells that promote the creation of bone. And normally, these cells express a protein. That's what hydroxyapatite looks like if it's not in your bone, I guess. They express a protein called osteoprotegrin. And osteoprotegrin will bind a ligand on other cells called rankle, and it does this super interesting thing where it does nothing. It doesn't do anything. OPG is a decoy receptor. So there's a normal thing that will bind. Oh my god. There's a normal thing that will bind rankle and have a real effect, But if there's overwhelmingly more OPG, the decoy receptor, then fucking nothing happens. And that prevents that is a mechanism to prevent osteoclast activity, which are they do the opposite of osteoblasts. They absorb bone to release the calcium. You can remember that by osteoblast B bone and osteoclast C cut. Yeah. So when PTH binds, it will upregulate the real receptor for rankle, which is rank. Do I remember what this stands for? I know the L stands for ligand. It's like something something NF kappa beta ligand. I don't know what the easy part stands for, but it doesn't matter. Rank is a receptor that binds rankle, and when they actually bind each other and we get OPG, the cock blocker, out of the way, it will activate the osteoclasts, and they will begin to digest bone and release the calcium and the phosphate from the hydroxyapatite. Thank you. Receptor activator of nuclear factor kappa beta ligand. I could do a whole fucking lecture on NF kappa beta too. That motherfucker is crazy. Thank you, Kenzie. So as you can see in the bone, parathyroid hormone does a similar thing as vitamin D, only again, it does it on a larger level, and this is kind of its focus. Vitamin D's focus is more getting it from the kidneys and the intestines. But parathyroid hormone loves the bones. So also unlike vitamin D, parathyroid hormone, when it acts on the kidneys, it does increase the absorption of calcium by a little bit. But mostly what it does is it increases the excretion of phosphate. Another way to say that is that it inhibits the reabsorption of phosphate. So it gets phosphate out of here. Vitamin D does not do that. Vitamin D does not function in pissing away our phosphate. That is all parathyroid hormone. That parathyroid hormone does not like phosphate. And another, as you can see, fun thing that it does is it increases the activity of 1-alpha hydroxylase in the kidneys, thereby increasing the active hormone of vitamin D. I mean, what a bro, right? Just so cool of him. Okay. Endocrine hell is really gonna happen now. We're gonna get into Arrowtown. So
Man.
Always while I'm drinking, she does that. Man. Let me make sure my arrows are straight.
Entering John Madden mode.
I'm entering John Madden mode.
Gotta add that as a react. We get like what was it, the NASA video game? John Madden.
John Madden. That'd be a good one too.
I need to watch that again. Okay.
Before we go to the arrows, this is where I want to point out why we do the test for 25-OHD3 instead of calcitriol, the active form of the hormone. And then I took an arrow to the knee in Arrowtown. That's what's we're about to take lots of arrows to the knees. It's gonna happen. But another reason why we don't test actual literal vitamin D in our lab tests for vitamin D deficiency is this relationship with parathyroid hormone. What happens is vitamin D deficiency. Vitamin D deficiency increases parathyroid hormone because it's a feedback loop. One of parathyroid hormone's functions is to increase this activity of this enzyme, right? And usually in hormone pathways like this, wow. That will occur because you have low levels of something. What's another example? Oh, if you have low cortisol, your brain will be stimulated to release the hormones that lead to more cortisol, corticotropin releasing hormone and adrenocorticotropic hormone. So there's we see this in a lot of other pathways where if there's not enough of the hormone of a specific hormone, then the hormones that lead to its creation will increase their activity. So that's why when you have low vitamin D, parathyroid hormone is stimulated to give us more active vitamin D. When that happens, though, uh, yeah, like it's upregulating the final enzyme in the pathway to give us more vitamin D. But if we're vitamin D deficient, that probably means that we're not feeding into the top of the pathway. Like we're not getting enough of the vitamin D3. So as we become more vitamin D deficient, and parathyroid hormone is just pushing all of the metabolites to vitamin D, then it's eating the precursors basically, then it won't really reflect our deficiency, because the parathyroid hormone is increasing the active form of the hormone as a result of it being low. So that's why it makes it inaccurate. If anyone is confused by that, I can try to explain it in a better way, but just understand that the 25-OH-D3 is a way better indicator of your vitamin D levels because it's in the middle of that pathway. It's going to reflect a lot better on what your actual levels of vitamin D are. Okay. So I think it's arrow time. Yeah. So here we have vitamin D raising calcium and phosphate. Parathyroid hormone is also stimulated not just by decreased vitamin D, but by low levels of calcium and high levels of phosphate. So that's pretty logical because parathyroid hormone increases both of those things technically by eating bone, but then it increases the excretion of phosphate in the kidneys. So, and this is cool. They're both sensed by ion sensors in the glands, like proteins on the, I believe, the surface of the cells of the parathyroid glands that just sense the concentration of ions in your blood. It's really cool. And it's interesting. Like parathyroid hormone directly affects calcium levels through its effects on bone, and indirectly through its stimulation of vitamin D. But they have completely different effects on bone metabolism. Because parathyroid hormone, of course, eats the bone, and vitamin D is really increasing calcium through its action on the kidneys and the intestines. For calcium and phosphate, which both of those increasing the levels in the blood, yeah, it has those functions that I mentioned earlier with muscle and nerve, but you're also increasing the pool of calcium and phosphate that could potentially be mineralized into bone. So, thus promoting bone remodeling. Where am I? So yeah, an interesting relationship between these guys, because of their function, their effects on our ion concentrations. High calcium inhibits parathyroid hormone. It makes them stop taking calcium from the bone. And high phosphate also. Oh yeah, the secret function. I called it the secret function of vitamin D is to inhibit the release of parathyroid hormone. But we kind of got that from the fact that lower levels increase parathyroid, higher levels turn it off. That's a negative feedback loop. We like that. So these arrows, man. Oh yeah, this is interesting. So high levels, I'll do it again. High levels of phosphate inhibit vitamin D, which makes perfect sense because it is actively increasing phosphate through its normal function. So it follows that when phosphate gets too high, that tells it like, all right, I'm gonna chill out. I don't need to take any more phosphate from the kidneys or the intestines. But why does it inhibit? It's weird that it inhibits parathyroid hormone though, because you would think that its action, PTH's action in excreting phosphate, you would think that you would want that to be activated by high phosphate. But in reality, that has to do with the final member of our endocrinological hell here, which is FGF23. There it is. It's released by osteoblasts in the bone, and it has a negative feedback relationship with vitamin D, in that vitamin D stimulates it, as you can see by the green arrow, but then FGF inhibits vitamin D production. Classic negative feedback pathway. So FGF23 also increases the excretion of phosphates like parathyroid hormone, and it also reduces the release directly of parathyroid hormone. So although PTH helps with the phosphate excretion, if phosphate gets too high, then FGF shuts that shit off. Because here's the thing. Even though parathyroid hormone is helping with the phosphate excretion, by eating the bone, it's also contributing to increased phosphate levels while the excretion is happening. So when levels get too high, it's a really nice shutoff to have where FGF comes in and is like, you're done. And FGF can just decrease all the phosphate at once without increasing calcium and without affecting bone resorption. Who thinks of this shit? Who made this shit? It's freaking nuts. I mean, how wonderful to just have this ability to affect your ion concentrations without even having to think about it. I mean, it's amazing. Fortunately, not everyone has this luxury. Not everyone has the luxury of such a well-oiled endocrine regulation, which is where vitamin D deficiency comes in. Oh, yeah, it leads to, yeah. So, I used the term Rickets earlier. Rickets is basically inappropriate development, inappropriate formation, inappropriate mineral deposits in bone caused by vitamin D deficiency. And rickets is what we call it in children. If it happens in adults after the growth plates have closed, or just after, you know, the final bone development, then it's called osteomalacia. And again, this X-ray is demonstrating the bow-leggedness of children who have rickets. There are specific parts of the bone that don't get mineralized, and there are other parts of the bone that get inappropriately mineralized. And it causes these sorts of deformities. It stunts growth, and it causes a lot of bone pain. So this is why we have vitamin D in milk. Okay. So vitamin D deficiency, it can be due to a nutritional deficiency. So if you're just not consuming enough vitamin D, which again is hard because not a lot of foods have it, or if you have a more often it's not it's that you have a calcium or a phosphate deficiency, and then those two are caused by vitamin D deficiency. So usually supplements, vitamin D3 supplements, are prescribed, or depending on the nature of the deficiency, getting more sunlight can help too. Usually in addition to the supplements though. Usually getting more sunlight when you have vitamin D deficiency is not enough to correct it on its own. So What if it's not a nutritional deficiency, though? It's possible to consume enough vitamin D and get enough sunlight and still have vitamin D deficiency, um, which is fucked up. You saw throughout this process that there are a number of proteins involved in vitamin D's function, and what that also means is more things for us to have genetic mutations in, more things for us to have that don't work. So there are a few subtypes of rickets and of vitamin D deficiency that involve mutations in, for example, some of the enzymes in the biosynthetic pathway. Let's take a look at those. I think I go back to that. Yeah, here we go. Cool. This is the pathway. I'm sorry that cholesterol looks so shitty, but it's okay because we don't care about it. There we go. This is fine. So one of the subtypes of rickets or vitamin D deficiency has to do with a mutation in the gene that codes for the enzyme 25-hydroxylase. So if that gene is not functional, you cannot convert vitamin D3 into 25-OHT3. And therefore, down the line, it also can't be converted into the active form of vitamin D.
Wow.
You can also, oh my god, you can have mutations in the gene that codes for 1-alpha hydroxylase as well. So if you have either of these two mutations, this is not going to work. Because what's the point? This is so behind in the biosynthetic pathway, and if you don't have one of these enzymes, it's just never going to reach the active form. It's never going to reach calcitriol. So generally, people with this with these types of mutations have to just take. They can be prescribed straight up calcitriol. I don't think it's over the counter, which is why we don't see it. But straight up, the active form of vitamin D can be prescribed to people who have this deficiency. But in general, they have to take it with calcium in order to keep up with their body's calcium demand. No, I actually didn't come across that. Vitamin C is the one that causes scurvy. If I can do an off the cuff, I'm gonna give myself like 5 seconds. People with fair skin. The only thing that I can think of is that I don't know, it has to do with clearly some like genetic, whatever the opposite of maybe genetic defect in the pathway, but I'm really interested in that now. I might be able to like look it up real quick at the end of that and we could talk about it. You know what I can tell you though is why people with super not fair skin are very prone to vitamin D deficiency, although you could probably think about why that is, but I'm almost done with the diseases. At the very end I'll explain that too, because I wanted to really quickly go into the groups of people that are susceptible to vitamin D deficiency, even if they don't have a mutation like this. But hell yeah, I will do that. Hell yeah. We're gonna freaking do it. So yeah, they can be given straight up vitamin D and calcium. Calcium is the big thing. And another thing, like don't forget about parathyroid hormone when you have a vitamin D deficiency. That means that parathyroid hormone is going to be increased because that's part of its mechanism. But if you have chronically low vitamin D, then PTH is going to be chronically high, hyperparathyroidism, which means that it's free to just continually break down your bone and take calcium from your bone and potentially lead to bone issues. Oh man, you do. You have a hyperparathyroidism. Your bones are peanut brittle. Man, that sucks. Ah, do you happen to know if you're comfortable answering this? Do you know if it's primary, like if you have a problem with your parathyroid glands, or if it's the vitamin D thing? I think primary hyperparathyroidism is really rare. It's usually the secondary one that's caused by vitamin D deficiency. It's the D, fucking D. Always the D. The last genetic, oh no, not this yet. The last genetic mutation can be in the frickin' receptor for vitamin D. You can have a mutation in the VDR, which means guess what? It don't matter how sufficient your vitamin D levels are, your body is not going to respond to it because the receptor is broken. So in that case, you just need calcium. It's not going to do absolutely anything to even give you the active form because the receptor's not going to respond to it. So the only way to sort of treat that is to treat whatever we know is going to happen if we have low vitamin D, which is the deficiency in the calcium. I didn't actually see, this was interesting. I didn't see anything about phosphate supplementation, which makes me think that there might be a lot of phosphate in food. But the big thing for treating people with VDR mutations was just freaking was calcium. Oh yeah. There are a host of other diseases, of course, that uh, are where vitamin D deficiency is implicated. Lots of like depression, ADHD, especially schizophrenia. Schizophrenia is really, really heavily associated with vitamin D deficiency. And I mean, like all the molecules that are just floating around in our flesh vessel, they do so much more than their names imply. And their names might also be lies, like in vitamin D's nuts. And they can turn out to have really surprising roles in random places. We love molecular biology. Oh yeah, I'll say really quick, if you like earlier I was if you have dark skin, then that means that you probably know this. That means that you have higher melanin. And evidently, melanin can block UV radiation, which sounds like it's really good, and it is. But when it comes to needing to start making vitamin D, it can impair you a little bit. Which is why if you have even if you get enough sunlight, of course, that's implied. But so if you have dark skin and you are struggling with vitamin D deficiency, then your best option is just to take supplements because here I'll go back to the pathway really quick. It's just this right here that would be impaired if you have high melanin content. Which in someone like me, I have very fair skin. So my body can very easily convert this into these guys. And if fuck, what was I saying? If this is the reaction that's being prevented, though, then luckily you can take it in this form right here because you could skip the light reaction basically. So even though it's really annoying to take a supplement, at least it is like a very easy correctable thing that you can do to compensate for any deficiencies. So yeah, that was vitamin D's nuts. If you guys have any questions, just feel free to give them to me. I'm gonna do that really quick thing because I'm very interested in what Gray said about white people and scurvy. I'm also wondering if I don't know, because I think of scurvy, I think of like in the 1700s, and I'm just like, Maybe, I don't know, British people. Freaking British people. The British Limeys were right. I'm not reading that article. That one is bullshit. Why do white people, why do white people age faster? Why do white people wear shoes in the house? Why do white people have small lips? And why do white people wear shorts in the winter? Oh my god. That is that's actually the best thing I've ever seen. That's wonderful. Scurvy still developed countries.
Wow.
Okay, I have one NIH article. Please be free. It's free. Still occurs in developed countries. We report the case of a 57-year-old man who presented with combined vitamin C and zinc deficiency. One man? We're reporting on one person for this study? Okay, the only thing I can think of right out the gate after skimming this is it's an epigenetic it's an epigenetic reaction to the Irish potato famine. You know, one of the only bad things to have happened to white people. Maybe? I'm just kidding. Yeah, wow. Oh man, they included pictures. Was not expecting that. And NIH, why? Nice. Yeah, Gray, I'm actually gonna have to look more into this because this study that I'm reading, they're doing it on an old white man. And I'm getting vibes that it's the old part of that is playing more into his condition than the white part, but I'm very vexed and I'm very interested. And I imagine it would be hard to find a study that implicates white people's skin in their condition because it's so default. It's so normal. Fucked up. But yeah. Oh, this was great. This was so, I mean, I had some trouble because of a power outage, but this was still easier than dopamine. I mean, dopamine had so many brain things. How could I forget about estrogen?
Yeah, baby.
So everyone knows that when your estrogen goes down a lot when you hit menopause, that's when osteoporosis kind of starts to set in. And in my research, I learned that estrogen in your bone, it acts to upregulate the no, go back. Upregulate osteoprotegrin. Go back. Which, if you remember, that is here it is. That's the decoy receptor that prevents osteoclasts from digesting your bone. So I thought that was really cool. I had no idea that estrogen had that direct of an effect on, like, specifically osteoprotegrin. So that is probably just one of the ways that estrogen is really, really good for your bones. And why, I don't know. I think I learned this like at the beginning of the college, but female bones, like, I think especially like teenage years, which is usually when you're like growing and you have weak bones. But we got dense bones during that time. Dense certain bones. But don't tell that to the two girls who broke their clavicles next to me on the lacrosse field. Or the girl who broke her femur in powder puff football and had to go to high school graduation in a big freaking like wheelchair with her leg all stretched out. Man, how do you break your femur in powder puff football?
Bend and snap.
The bend and snap. Oh my god. That's hilarious. I know, the femur, that's like the densest, biggest bone in the body. It does not sound fun. I would hate to like be forced to have my leg like outstretched while it's healing. God, this sounds like. I wanted to find more stuff about estrogen and vitamin D, but I didn't find anything definitive because I think people are still kind of figuring it out. But the thing about OPG was pretty fascinating. Yeah, I don't like either of those. I think the worst bone I've ever broken was my tailbone. I did not like that. Did not. I've broken tailbone, rib, ankle. I think that's it. You bruise your tailbone? That is fucking painful. I don't like it. An HRT stream, like information on HRT?
Yeah.
And how it affects your body and what the hormones do? I would love to do that.
Well, you already have your SRY.
No, Sonic Hedgehog is coming up.
I mean, I know you have SRY in the polls.
Yeah. You fell in a soccer game? That fucking sucks. Yeah. Not my favorite. Not my favorite at all. That does remind me. I believe it will be the weekend, the Monday. Next week is off week, and then Monday the 14th. I'm gonna talk about Sonic Hedgehog. Sonic Hedgehog.
Does it go fast?
It goes very fast, and it will be. We're gonna cut so deep into molecular biology. It's gonna be thick. We're gonna be nauseated, but we're gonna love it.
We're gonna cut so deep. No one's gonna cut deeper.
No one is gonna cut deeper than me.
No one's cut deeper before. Cut.
Oh my god. Yeah, Sonic Hedgehog. A real protein that some nerd who loves Sonic the Hedgehog. I think the protein was discovered and named in like 1994. Fucking named it Sonic the fucking Hedgehog. That's okay. We love it. All right, y'all. Thank you so much for hanging out and for listening. I love talking about this stuff. I love talking to you guys. I love hanging with you guys. It is the best. So many arrows. If I wanted this many arrows, I would have studied biochemistry. Anytime, my friend. All right. Hopefully, I will see you guys in a couple weeks. Dick. Vitamin Dick. Vitamin Dick. I'm trying to say vitamin Dick. No, vitamin Dick. I mean cock. Diet cock. All right. Y'all are my favorites. I'll catch you on the flibbity flabbity. Amy is never invited to a stream ever again. I'm just kidding.
I don't have to be. I'm in the fucking cutting room. I'm in the fucking production room.